Hi there, it's Professor McDonald, and I'm about to answer your questions. Today is January 28th, and if you're in one of my fully online classes, I do this twice a week. On Monday afternoons and on Thursday afternoons, I go through my Lumen-Ohm inbox to see what kind of questions you have submitted and go ahead and answer those in video solution format. Today, I've received only one question since my last recording on Monday. Now, this is concerning to me because we do have an assignment due tonight at midnight. So I hope that students are taking advantage of the SLC tutoring online. I have not seen students coming to my Zoom office hours to ask for help either. So it's a little bit curious. I'm hoping that you guys are doing okay on your assignments. I'm expecting that maybe some students are waiting till the last minute and there's going to be a bunch of questions in my inbox when I wake up tomorrow morning. It's just too late to submit questions if you wait until Thursday. You really need to submit your questions before Thursday and before Monday in order for me to be able to answer those in these sessions. So just wanted to put that out there for you guys. If you're wondering why you haven't received answers to your questions, it may be that you submitted them too late. And so the one question that I did receive is actually not this question, but this one right here. But before I get into answering this question, I felt it was very important that you understand what box plots are made up of. Box plots are made up of 5 number summaries, which include the minimum value, the first quartile, and the first quartile is also known as the 50th percentile. So, I meant to say 25th percentile, forgive me. Remember, a quarter is 25%. So a quartile divides the lower 25%, and that's the same thing as a 25th percentile. Then we have the median, which is also the second quartile, and it's also known as the 50th percentile. So 2 quarters is 50%. So the median divides half of the values from each other. And so now we have the third quartile, which is also known as the 75th percentile. 3 quarters is 75%. So the third quartile is the dividing line where 75% lie below that number and 25% of the population is above that number, or 25% of the sample, as the case may be. And then we have the maximum, which is the largest value in the data set. So now let's use some abbreviations here. Q sub 1 will be how we denote the first quartile. We'll just say median, or we could just say mead. The third quartile will be Q sub 3. And also these two right here and right here, the first quartile and the third quartile are known as your interquartiles. So the interquartile range is another thing you deal with, and that's interquartile range is abbreviated as IQR, and that is equal to Q3 minus Q1. And we use that to identify outliers. So if you've seen, I'm just going to not put the subscripts to make it a little less busy here. And so if you've seen any questions where you're identifying outliers, remember you're going to take the IQR, subtract Q3 minus Q1, and multiply it times 1.5. And you're going to use that to find your fences. The lower fence will be the dividing line for values that are not outliers. Anything that's less than this number would be considered an outlier. And so you would calculate that by taking your first quartile and subtracting 1.5 times the IQR. And to get your upper fence, so any values that are beyond this number will be considered outliers. And so it's Q3 plus 1.5 times the IQR. All right, so all of this information can be found in your textbook. and in the reference packet. Much of this is also in the reference packet that you're allowed to use for tests. But we're focused on the 5-number summary because the 5-number summary, really, because we want to be able to use it to make a box plot, and we want to have a data set. Let's use this example here on my left. There's 40 values here, which represent heights of students in a certain statistics class. Now, they're already laid out in order. You also have a sort option. If you go up to data in Excel, you can use the sort option if your values are not in order, but these have already been ordered. So we can see that the minimum value is 59. We can also see that the maximum value is 77. So that's easy. Now what about the median and each of the quartiles? Well, first of all, we have to ask the question, what is our sample size? We said it was 40, and it represents your sample size. So we have 40 values in our sample here. And we can use that number to divide up the sample into sections, into quarters. So what is 1/4 of 40? You can calculate this. Now, many of you probably already know the answer is 10. 10 is 1/4 of 40. But what you can do is you can calculate 25% times 40, and that will give you the 10. Or you could have said, what's 40 divided by 4, right? And so our quarters are going to have 10 values in each quarter. So let's go ahead and kind of section this off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's my first quarter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My second quarter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Third quarter. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 makes my last quarter. Now, since this came out evenly, the dividing lines are very clear between two values. So we're going to take the average between those two values, and that would be 64.5. So that'll be my first quartile. The median is going to be, let me zoom out for a second. It's going to be the two bottom quartiles divided from the upper two quartiles. So we're looking right between these two values. And since they are the same value, when you average them, you get 66. So that's the median. And finally, the third quartile is the dividing line between the third quarter of values and the fourth quarter of values. So again, we see 70 and 70 averages out to 70. Now you would use those to make a box plot. And let me show you the example from the textbook. Okay, so you can see here the box plot is laid out on the number line, where you can see the minimum value at the end of the whisker here is 59. The maximum value is 77. The box on the inside represents the interquartile range. So the first quarter is 64.5, the first quartile, the dividing line, and the third quartile is 70. And right there in the middle in the dashed line, that represents your median, 66. So that's what our box plot looks like, and it is a little bit skewed inside here, but not too much. And that gives us a good feel for how the values are distributed, the heights of the students in the class. Notice that there's a lot of students right in this section, around 5.5 feet, because this is in inches. So common height between 5 and 6 feet. All right, so now that you know what a box plot is and how it's laid out, how we come up with those values, let's look at this example. It says the box plot below shows salaries for construction workers and for teachers. So we have them laid out on top of each other on the same scale of salary in thousands of dollars. And then it asks if a person is making the median salary for a construction worker, they are making more than what percentage of teachers? So first of all, let's identify the median salary for a construction worker. So I'm going to use hot pink because I know construction workers probably love wearing hot pink. And we have the median there in the center. And remember, that is also your second quartile or your 50th percentile. So that means that when you look at the values from here to the left, or if you just look at all the um, construction workers who had salaries that were lower than 40,000, that would be 50% of construction workers make less than $40,000 a year. Now, we were asked though about teachers, right? So for the teachers, they are making more than what percentage of teachers? That's another question, right? Well, $40,000 for the teachers lines up at, let's go ahead and write it in, at, what is this? This is the third quartile, right? Or in other words, the 75th percentile. So all the teachers who make less than $40,000 are represented down here, and that is 75% of teachers make less than $40,000. So the answer is 75%. So again, let's read this. If a person is making the median salary for a construction worker, okay, right here, $40,000, then that person is making more than what percentage of teachers? So they switched it up on us. So in other words, if we look at these statements that I have written down here, if we look at the people who make $40,000 a year are paid better than 50% of construction workers because 40,000 was the 50th percentile or the median or the second quartile. And another way of talking about these values is to compare them to teachers' salaries and say that people who make $40,000 a year are paid better than 75% of teachers. All right, so that was my only question. I'm going to pause this and just double check my inbox to see if anything else has come through before I close. Okay, I checked and there are still no more questions from students, so best of luck to you all. You will see another video posted for you on Monday answering your questions from the next GLA. So all the best and have a great weekend.